Hey everyone, welcome back to ACT Math Quick Hits, where you can make this one small change and watch a video a day. It doesn't cost you any money, only costs you a little bit of time, and you're going to help improve your ACT math score. There's the rundown of the math section of the ACT, so let's get back into it for today. Alright, so today's question says, let the slope of 3x plus 2y equals 5 be some value m sub 1, and the slope of a second line, 6x plus 4y equals 7, be some other slope m sub 2. So which of the following is true, right? And it gives us a bunch of different relationships to these slopes. Okay, so in going through this one, we can use Desmos, and actually today's, I think Desmos will work pretty well. However, if you encounter a question like this on the ACT, it might not always be this easy. So let me go through it algebraically first, and then we'll show it on Desmos, just so you can see both ways, just in case when you get a question like this, it doesn't end up being so straightforward, I should say. All right, so they give us two equations of lines, and they give us those lines in standard form. Well, if we're in standard form, we can't identify the slope very easily. But if we were in slope-intercept form, which is y equals mx plus b, then we can identify the slope pretty easily because the slope is just that m value. So if I wanted to get these both into slope-intercept form, I would just solve for y, meaning get y by itself. So in both equations, I'm going to do that. So I'm going to show us how to do it algebraically. So I'm going to subtract 3x from both sides. So our first equation, we end up with 2y equals 5 minus 3x. And then to get the y by itself, I divide by 2. Remember, I have to divide this entire side by 2. Doesn't necessarily matter for the y-intercept part right now, but it's just good practice. So the 5 gets divided by 2, so we have 5 halves, and then the negative 3 gets divided by 2, so we have minus 3x over 2. So here's my slope, right? The number that is connected to the x. And I guess I should circle the negative 2 because it's a negative 3 halves. So I'm doing the exact same thing with the other equation. I'm just going to get the y by itself. So I'm going to subtract 6x from both sides first. So I have 4y equals 7 minus 6x. And then divide both sides by 4. Again, it doesn't necessarily matter as much with the y-intercept because we are just concerned about the slopes. But like I said, good practice. And then we got minus 6x over 4. All right, so we have a fraction that we can reduce here, right? This negative 6/4. So I'm going to do that real quick just to help us compare. And what do we get? We get negative 3 halves, right? 2 goes into 6 3 times, 2 goes into 4 twice. And again, notice I didn't write the equation the exact same, right? I wrote it as y equals b plus mx. That's okay. Commutative property of addition allows us to add these numbers in any order together. But if you notice now, right, both of these slopes are the same, right? Both of these slopes are this negative 3 halves. So that tells us that we should use choice A, or select choice A. So that's how we would do it algebraically. I wanted to show you algebraically because, again, if you see a question like this on the ACT, it might not end up with them both being the exact same. Now, Desmos will do this for us much quicker than that algebraic piece. All we do is we put both of these equations into Desmos. Whoops, not 7, 5, right? So there's our first one. And then 6x plus 4y equals 7. And right, it's pretty easy to see that these are two parallel lines, meaning they'll never intersect, meaning their slopes are the exact same, right? So that helps reinforce that it's choice A. But like I said, you could end up with a question like this on the ACT where the slopes are, one of the slopes is twice as big as the other, right? Which would be like either choice B or choice C. And that would be harder to see or harder to determine on Desmos, right? Maybe they have an answer choice that's like 3 times as big or something like that, right? And so you would see two different slopes, but it would be really hard for you to be able to tell like what those slopes are. Now with Desmos, you could calculate the slopes by finding some points and doing the rise over the run, but it's hard to find like some good lattice points, and like it's a little bit, Desmos is kind of a little bit tougher to pick those points, right? Like I'm getting kind of, I can't really zero in on that point right there. So for this question, in particular, Desmos actually does pretty good, is fast and does a good job because, right, we just have two parallel lines being the same slope. But like I said, if you see a question like this on the ACT where they're not the exact same slope, then the algebraic approach is probably going to be a little bit better because it will allow you to see that exact relationship. All right, that was a lot of talk. All right, thanks for watching, everyone. I know that ACT Math Prep is not the most exciting stuff out there. However, your future self would appreciate it if you like and subscribe. That way you keep getting these ACT Math Quick Hits. Learn a little bit about algebra, learn some Desmos hacks when we can use it, and improve your ACT math score. Thanks again, everyone.